Hello, welcome. Today we are going to cover the basics of object-oriented programming in Python. So this is for beginners, and we will cover a refactor showing why and its useful object-oriented programming, and we will demonstrate it live with examples. Okay, so first of all, let me address a message for the Spanish speakers. So basically, if you are a programmer that have the Spanish as a native language, OOP, Object-Oriented Programming, is programación orientada a objetos, but don't send CVs telling that you are an expert in POO, because in English POO has another meaning, so use the acronym OOP. That's my first advice. Okay, so now let's get serious. So you can clone the repo from here, from several examples from the blog. You can see my blog in here and see the Twitch channel. And we are going to start a new file, Python file, and we want to say OP begin. Yes, later we will commit. I'm going to enter now the presentation mode. So you will see the font bigger. Enter presentation mode. Okay. So this is maybe too much, but let's try how this works. So basically, we are going to start a program when we want to deal with the data of employees, and we want to use in a procedural or traditional form, we want to deal with this data. So I'm gonna start with, first I will do this. That's something that you should do in all your programs, because if your program is imported from another Python program, this part will not be executed. As if you want to reuse the functions that you have created on top in here, this part under the if underscore underscore name underscore underscore will not be executed, because in import it's not equal to main, only when you directly launch it from CLI, from command line. So let's proceed. Okay, so let's imagine we have some names for our company. I'm gonna express like that. I'm using this prefix as s underscore for meaning the intention that I want this variable to be a string. It's just a convention, so it's very clear what's the intended purpose of a variable. It has no, doesn't affect the language. So okay, I'm gonna name the first Edu, because he's a very good friend. And I'm gonna say that the city of Edu is Barcelona. I'm gonna say, for example, that salary of Edu is 200,000 euros gross per year. He deserves that, of course. And I'm gonna add some more names. For example, I'm gonna add Maria, and the city maybe in Ireland, in Cork, and the salary maybe 120,000. I'm gonna, oh sorry, you see in yellow that is pointing me that I'm overwriting a variable. So I'm gonna name this 2. So I'm gonna do the same, name 3 equal who is Sid for example, and city 3 we can say London, and we can say salary 90,000, and I can say name 4 Mihela, and city we can say Dublin, and we can say a salary for example. Okay, so now imagine that we want to we want to print, thanks, Chef. Imagine that we want to print a listing with all this data. So we will do something like print name, city, salary, and to be consistent, I'm gonna rename this to name1. To be more consistent, I'm gonna use the functionality refactor. So I'm gonna change this to name1 and only for the current file. Refactor. Okay, I'm gonna do the same. I'm pressing Shift X6, so I go directly. One for the current as well. Refactor, and the same in here. One, and the current file only. Refactor, and as you can see, it has refactored the usage, which is very handy. So now I'm gonna copy this, and I'm gonna say 2, 2, 2. I'm gonna say 3, 4, 3, 4, 3, 4. Okay, so if we run this now, let me keep the headers. Yeah, so run, not this one. Let me see. This one. Okay, so it prints it. Okay, so now we want this to be a bit more nice because it's not aligned, and so let's imagine we want to say, okay, left justify this. I'm gonna keep 9 characters to the left, so you will see that it will be a much more nice. So run. You see now it's justified to the left, and I can justify this to the right, for example. So it will be r_justify. I'm gonna keep 11 characters just in case. If we put a big city, for example, run. Okay, and finally I'm gonna justify the salaries, as it's an integer that comes handy here, seeing the I for integer. First I have to convert to a string, because I cannot justify like if it was a text and a number. So first I convert to a string. And we do the same here. And once this is converted to a string, then we can write justify, and we can say I see 6 characters, so I'm gonna keep 8 positions for the justify. So I'm gonna do this. Okay, so now if we run this, it looks a bit more nice. Okay, now imagine we decide that we don't want to display the city. So, okay, now I have to change this, and I have to change in 4 places. And if we have this code like 20 times, I will have to check to modify 20 times, which is really a pain. So now I run it, and we don't have the city anymore. Okay. So for this, we have what we call the functions, or we can use in procedural the function. So I can say, I can create a function which is name print employee information, and then I can pass here the name, I can pass here a salary or a city, and I can pass here the salary. And it's nice to be nice. It's nice to document. So about a employee. Nice. There will be no return. So basically what I will do there is this, but instead of name1, it will be name and salary. And now, instead of this, I can just call print employee information, name 1, city 1, and salary 1, and I can do this for the fourth people. 2, 3, 4, 2, 3, 4. Okay. Fantastic. So now we have the same. I'm gonna follow the standards, 2 lines, 1 line at the end. Fantastic. And as you see, in light green is city because it's not being used. So now we run this and we get the same result. And if we want to add the city again, we can just put the city. I'm gonna justify. I'll justify. It was right justified, and I'm gonna keep 15 characters. Okay, so I can run this. Nice. So we see that the advantage of having this in a function is that we can quickly change how it will behave, and we don't have to change like in 4 or 20 or 2,000 places. So we try not to repeat our code. Also, we could have like do this even better, and we could have, say, instead of name 1, city 1, salary 1, etc., makes more sense to have this in an array, for example. I will call this array names, and I can have Edu, I can have Maria, I can have Sid, and Michela. And I can do the same for the cities, and I can have Barcelona, I can have Cork, I can have London, and I can have Dublin. Nice. And I can have the salaries as well. Array of integer salaries equal, and then I can say salary 1. Oh, well, instead of that, I will just type them again. Okay, so now I can delete this, and I'm gonna delete this as well. Or I'm gonna keep one line, just one line, and then I'm gonna go for that will be, instead of 4 I will do a while. Okay, while counter is less than the length of names, then I initialize the counter to 0, or more than pointer, I will call it pointer. Okay, then I will say, okay, you will print from the array pointer from the array of city. I'm gonna fix this because I made a mistake. Pointer, that's names, and this is for the array of salaries pointer. So if I didn't do any mistake, that should work. Run. Oh yeah, I did a mistake. A pointer less than len. Oh yes, but yeah. I didn't realize that. Okay. Okay. Oh yeah. So what happened here? That obviously I'm not increasing the pointer, so it's running. Edu is multi-millionary now. Okay. So what we will do is increase the pointer. This is the same as doing this, but for clarity, and as I don't know the level of everybody here, I do in the long format. I prefer also to make the code more clear, Because after a long day programming, if you are looking for a bug, the most readable that the code is, the better. So I'm going to remove this line here. And if we run now this, okay, we see that we have that same result. Just to finish, we could consider another thing. Let's imagine that we want to increase the salaries for our employees. Then what we will do is, okay, to make it a bit clear, salary equal to this. Now we increase the salary at 10%. So we will say that the salary is equal to itself multiplied by 1.10. The explanation of this is that the long form of this will be the salary is itself plus a 10% of itself. But this is the same as doing, just to make it clear for you, 100 per 100. So the 100% of the salary per this. So that could be expressed as 100 divided by 110 divided by 100 of the salary. And 110 divided by 100 is 1.10. So to simplify, we do like that. First time you encounter this may be a bit complicated for you, but after more time that you do this kind of exercises, comes naturally. So now I'm gonna update. I'm gonna update this because I want the array to be updated with the latest price. And you will see that even if I name integer, you will see that the output will not be integer because we are getting a float. But let me show you. Okay, you see, and that's one of the things of the floats. The computers don't know very well how to deal with floats, so it's an approximation. So you see, really the 10% of 200,000 is 220,000 pure, but the computer doesn't deal with it in a perfect way. So it's something that it's interesting to know for you to know as well. And okay, so if I want to have an integer, I will put here int. But before, let me show you something to make it a bit more clear. 755 177. For example, if we run like this, we will see more decimals. Yeah, yes, not that many as I expected, but that's okay. So you get the point. So the thing is, if I want to work with integers, what I will do is cast to integer this, which will remove the decimal part. There are several strategies for this. You can round by casting the decimal part completely, or you can round by approximating. For example, 220,001.7 will be converted to 220,002. And if it was like .1, .2, .3 or .4, it will be not converted to the next available position. Okay, so we have the code as we wanted, and we see that it's a bit of a mess. Even if we improve it since the beginning, it is a bit of a mess. Increase the salary 10%. And it's complicated to follow. Oh, sorry. This is to the right. Okay, so that's the procedural code, or the typical code that we were doing like 20 years ago, or even more. And then it's when it comes like the object-oriented programming, and the object-oriented programming comes with an idea to be one single entity able to deal with the data and the code that affects that data. So basically, we will have here an object named employee. So I'm gonna do this class employee, and here the class is like a blueprint from what we generate new instance, which are like, it's like if I have a blueprint of a car, for example, a Toyota Prius, and then I want to create one. So the blueprint is the class definition, and then the actual new car is an instance of the class Toyota car in this case, or Toyota Prius. And the same for a Volkswagen Golf or whatever. So when this blueprint is instantiated, so when a new employee object is created from this class definition, the first that is executed is the constructor, which is optional, but we use almost always. You may not have a constructor in a class, but normally you will. So, and what this constructor is gonna get are the fields that define this employee object. So we have the name, we have the city, and we have the salary. Okay, and we may add another field like the year where the employee started, year started, for example, or make more sense to have like a full date, date, employee started. All right, so now what we're gonna do is we are gonna define those properties as class instance variables, what are basically variables that belong to that instance that we have created. So for any new employee that we that we spawn, we will have a variable that we will call name, and I'm gonna call it name employee, just to make it clear that it's different from this name. I mean, self.nameEmployee doesn't have to have the same name as the parameter we get, and I want to make this very clear, so I'm more explicit in here. City employee. I'm gonna self.salary employee salary and self date started employee. It could be the same name, but I wanted to differentiate because that's a common doubt that my students ask. All right, so far, if now we did that, for example, object edu will be employee, and we will have for name edu, for city Barcelona, for salary we will have 200,001 to 200,001, and for date started, let's say that we have this one. I don't overcomplicate. So if we run this, we will have nothing. But I can introduce a line at the back line so you see how the constructor works. So employee registered, and I can debug here the name. I can refer to itself. It's the same Okay, let's do this. So you see that when this happened, the constructor, when we come in here, the constructor is executed, and then we print this line. Okay, we don't need it anymore, so you have seen. That's it. Fantastic. So now we are gonna create a method. Method is the same as a function outside any class, but in the class context. So basically, a method refers to the functions of a class. But we use the proper language in order, the proper wording, in order to do not have confusions. So I'm gonna define this print employee information as well. So I'm gonna define print employee information, and when we have a method that is from a standard class, like is in this case, we have to, the first parameter is always self. So I'm gonna copy this, or I'm gonna do from the start so it's more clear. So prints information about the employee. And as we pass this information on the constructor, all the functions in the class have access to this data. So we don't need to pass those parameters because we already have. So I'm gonna just copy this. And the thing is that I have to change to the right names, and to access them I have to say self dot is name employee in this case, and in this case it will be self dot city employee, and in this case it will be self dot salary employee. Okay, that's it. Perfect. So if I call now edu.print employee information, and I'm gonna finish the code here with an exit, so the rest of the code is not printed. So the execution will stop here on the exit. So run. We see that it's listing, is printing the information for edu. So now, having this in mind, let's do the same for the other people. So I'm gonna have what were the name? Maria, Sid. Okay, I'm gonna have Maria. Oof. Employee. This is Maria. We say that's Cork. We say it's that's a low salary. This one. And what else? What was? I'm missing something. Oh, we introduced the datas. Okay, I'm gonna do the same for the other employees. So it will be Sid. Sid, we said London, and we said 90,055, and we say 97,75. And finally, we have Mihela. We say Dublin, and we said this. And all right, I'm gonna say like this. Fair enough. So I'm gonna remove this. So basically, we have now you see the yellow. Those IDs help a lot, really. So it's pointing errors that I didn't realize because I copy and paste. Mihela. Okay, so now I can destroy this. I can delete this. I don't need it anymore. And probably what makes sense is to have an array of employees. And for this array, the items that this array will have will be the objects that I have created in state. Maria, Sid, and Mihela. Fantastic. So then I will compare to the length of the array employees in here. And for the salaries, okay, then for the salaries, instead of having this mix of data, what we'll have is a new method that says increase salary, and we can even like say, okay, what's the percentage that we want to increase, and I'm gonna say that this is a float percentage because I want to be able to increase like 10.5. Thanks, chef. Many thanks. I try to put real sample examples and do a full refactor, so it's very well understood why we do things like that. Here is the salary of the employee and stores as integer. Let's imagine that our multinational doesn't want to store floats, wants to work only with integers. Okay, there is no return, and as we use like variables that make sense, with like percentage, I don't need to put a description in here, like explaining what is a percentage or that is a float, because I started it with f underscore and it says percentage. What I don't recommend is to use variables like I, j, k, or a, because then the code, nobody understands what's that. So okay, so what we are gonna do is, okay, self dot salary employee, it's equal to itself per the percentage. Salary of the employee. What can I say is, for example, 10.5. All right. And I don't need to return anything because I'm updating the salary. So here, instead of doing this, what we can do is, okay, the object employee is equal to the array of employees for the I pointer, and then what I'm gonna do is O employee, whatever employee is in this cycle, increase salary, and I'm gonna say 10.5% to make it a bit more spicy. So now I don't need this, I don't need to update the array, and I don't need to call this print employee that we have before. In fact, okay, I'm gonna destroy this function because we don't need it anymore. Oops. Only will cause confusion. We have everything in the class now. So instead of this, I'm gonna call employee dot print employee information. Okay, so now we run the code, and we see that we have the same. Okay, we say that we want the salaries to be integers, so this we wanna convert to integer before storing. So now, okay, now it's better, and fantastic. Then imagine that, well, we are gonna refactor this a bit more. Imagine that I have another employee, which is Che. It's a Catalan name. It's the short for Meritxell. And I'm gonna say that she lives in Sant Feliu de Llobregat, and I'm gonna say she gets 99777, and maybe she joined in 95, 1, 2. Okay, so we have, oh, sorry, and this is Che, and I'm adding to the array. So you will see that now we are breaking the listing, the formatting, because this line is longer than the rest. So then we can fix that. We could fix this in here, but so I can do something like this. Still, I need a bit more, but doesn't make, okay. If another colleague looks at the code, will not understand why this is a 24, for example, or it's not very clear. This is what we call a magic number, in the sense that it doesn't have like it's just a number there, and maybe people don't know why it's being used. So we can define some variables for this in this case, and I'm gonna call it white column employee city. Sorry. And this is in uppercase because it's intended to be a constant. And I'm gonna put here a 24. And this is what we consider a static variable. That means that this variable is not a particular property of the employee. It's not different for Edu or Maria or Sid or Chel or Michela. It's common to our blueprint. So now what I'm gonna do in here is I can access this, name it itself, white column, but it makes more sense to name it by the name of the class, because it's more clear that it's not an instance class variable. All right. This is the one, class attribute. So now I will do the same for name, white column name. We said 9, so I'm gonna do this as well. Employee dot white column name, and I'm gonna do the same for the salary. White column salary. Okay, and we say that's 8. So that's white employee dot white column salary. Okay, and if you want to not having the line too long, you can show it as this, and if we run it now, it will work the same, but now our code is like more clear. Then there is another thing that we may want to do. For example, this listing is not very clear what is every column. So what we are gonna do is like to print a header. And in this case, the header is not something that belongs exactly to the employee. So the header will be the same for all of the employees, and it's not depending on the data that it's there. We will have a header even if there is not any data at all. I mean, if we don't have any instances of employee, we may want to print the header anyway. So you see that there is a disconnection between the typical data that we use when we need an instance of the class employee, and when we just want to have something that affects without any data to the employee. So for this, I'm gonna define a new method which is called print header. And you see, okay, I'm gonna put here pass. I could use any of the employees, or I could do any of the employees to call this method. Like I can do edu.print header. But as I said, that's not what I want. I want to print the header in here, even if I don't have any data. So let's first print the header, and then we will go with this. So basically, what I want to do is the same as here, but I will have no data. So instead of the name of the employee, what I want to do is to have a string like I will use the equal sign to make, the string that I want is the name of the employee, so it will be justified, and I want the city. Those are the labels for the city. Sorry, I will remove this. And this will be the salary, so I don't need to convert to a string because it will be a string already. Salary. And let me show what I want. So if I want to print the header, I can do object edu print header. So if I run this, name, city, salary makes more sense for a listing, but even more I want to add line separator, kind of line separator. So I will print an equal sign as many times as I have this plus observe, that will be employee white column. So if I do like that, I will have equal repeated as many times as the length of this column. So you will see that where I'm going. You see, I'm gonna now do for the rest of them. So I'm gonna add an empty space here, and I'm gonna do the same, equal employee dot column city, because in Python you can repeat a string just multiplying by a number. For example, let me show, let me make it this big. Okay, so Python 3, if I do this per 5, it returns me 5. If I say hello world per 5, it says hello world, hello, it's exactly. So that's what I'm doing. Basically, I'm adding a nice line separator for this listing to be easier to read. Employee.white column salary. So the equal per. Okay, so that should do it. Okay, fair enough. That's nice. Okay, so but now I want to print this on the header, because maybe I don't have any data. Imagine that we are reading this from the disk, and maybe the database doesn't have any employee. So I want to print the header anyway in this case. So I would like to have this on top, but I can't do this because edu has not been defined, and maybe there is no data. So what will make sense is to have like an static, the same way we can access this statically. So I can say print employee.white column salary, and I'm gonna exit here. And then we can access that data from outside without having any instance. The same way, there is the same mechanism for methods in classes. So in this case, it's called an static method. And an static method doesn't have self. And in Python 3, we have to use this decorator, static method. Don't worry too much about it. It's the way. Don't anticipate yourself, and because the decorators are entire world in Python, but just know that this is the way to define an static method. In this case, print header. So now we are able to use employee.print header without having any data. So if we do just run, we get now this comes from an static, and those are individual calls from any object employee. So this makes a lot of sense from the initial procedural code we have. This refactor allowed us to have a very clear code, and it allows us to extend the functionality very easily. So for the next week, I will cover the inheritance. So you will be able to override, and you will be able to extend from parent classes. But this is the main concepts that we need to have, like static properties, static methods, like instantiate a class, and that an object, an instance of an object which is an instance of the class employee, is like generating from a blueprint, that in this case is the class employee, generating that new spawning that new object that is employee and defined by its blueprint. And we see that our code allowed to do this very easily. So next week we will continue with this. Thanks for coming and for the questions.